Some say the world will end in fire, some say in ice. From what I've tasted of desire, I hold with those who favor fire. But if it had to perish twice, I think I know enough of hate to say that for destruction, ice is also great and would suffice. In about 5 billion years, the sun will swell to its red giant phase, engulf the orbit of Mercury and perhaps Venus, and leave the Earth a charred, lifeless, magma-covered rock. So, fire. That's settled. Frost was right the first time. But he wasn't thinking big enough. I'm a cosmologist. I study the universe as a whole on the largest scales. What matters to me, professionally and personally, is a bigger question. How will the universe end?
Hello, everyone. I am Bob Lingle of Off the Beaten Path Bookstore in Lakewood, New York. I am here tonight with Dr. Katie Mack. Katie is a theoretical astrophysicist exploring a range of questions in cosmology, the study of the universe from beginning to end. She is currently an assistant professor of physics at North Carolina State University, where she is also a member of the Leadership in Public Science Cluster. She has also been published in a number of popular publications such as Scientific American, Slate, Sky and Telescope, Time, and Cosmos magazine, where she is a columnist, and she can be found on Twitter as @AstroKatie. Thanks for joining us tonight, Katie. And I also wanted to, before I forgot, thank Abigail at Simon & Schuster for helping set up this event, and the Martz Cole Observatory in Frewsburg for helping promote our event tonight.
Thanks for having me.
So before we get into the deep thick of your book, The End of Everything, Astrophysically Speaking, I wanted to acknowledge that you recently celebrated 2 life moments. You successfully circled the sun another time, so happy belated birthday.
Thank you.
And you also recently successfully received your pilot license.
Yeah, that's been kind of my big pandemic hobby has been to learn how to fly airplanes. I think as a kind of extreme reaction to lockdown, all my other hobbies went away, and I found out that there was a airport nearby that was still doing flying lessons, and I needed to get out of the house, and so I learned how to fly airplanes, and it's been hugely fun and just an amazing thing to be able to do, especially because I know that it's been a really difficult time for most people, and some difficulties of my own, but being able to do something big and new and exciting has made things a lot better.
So some people learned how to make bread. You learned how to fly an airplane.
Yeah.
Is that something that has been in the back of your mind, or just that you did?
Yeah, so I've thought about it because I applied to the Astronaut Program, and one of the things that they ask you when you apply there is if you know how to fly airplanes for various reasons. And it was never something that I could do before because it takes a lot of time and it's expensive, and I did not have either time or money until recently, and then during this whole phase when everybody's working from home and there's no other events, no other travel going on, suddenly I found that I did have the time, and the financial situation is better for me than it was before. So I thought it was a good moment to check it out, and then I just became totally obsessed with aviation.
That's great. Career change for you, or are you gonna?
No, no. It's just, I mean, unless NASA hires me, and then I will go to space. But no, I'm still, very excited about doing my research and and teaching and the whole professor thing. But flying it's a nice thing to be able to do, and it's something that, when the astronaut call comes out again, I will put in another shot. But most likely it'll just remain a fun hobby.
So for your current career, depending on the bio, I see astrophysicist, I see cosmologist. Are they interchangeable, or is it depending on what you're studying at the time?
Right. So astrophysics is the study of, the physical processes of the universe, of stars and planets and galaxies and all of that. And cosmology is really the study of the universe as a whole. So the evolution of the cosmos, its beginning, its end, the physical processes that govern the evolution of the cosmos as a whole on the largest scales, and also the fundamental physics of the universe at the smallest scales. So there are two topics that do overlap. You can consider one a subset of the other in some ways, but I depending on who I'm talking to or what I'm talking about, I will describe myself in those two different ways. But I am an astrophysicist who does cosmology, or I'm a cosmologist on the astrophysics side of things. It kind of, they all run together in some ways.
And your interest in cosmology goes back until you were about 10, you said?
Yeah. So, a lot of astrophysicists, when you ask them how they got into it, they'll say that, they grew up looking at the stars and dreaming about outer space and the planets. And that was not really my experience. I grew up in Los Angeles. The sky was pink. You did not have these amazing, beautiful, vistas. You could not look out into the cosmos. So I really got into it through the physics side. I was the sort of kid who wanted to know how everything works. I was always taking things apart and putting them back together. And when I started to learn more and more about physics and things like black holes and space-time and the Big Bang, that was really exciting to me as something that was, these are big fundamental questions, and I wanted to get to the bottom of how does this work? How does that work? What's governing the universe? And so I really got into astrophysics and cosmology through the theory side, rather than through, pretty pictures of space, which is a different pathway. A lot of people do come into it through. So I think 10 years old is around the time when I read A Brief History of Time and learned about Stephen Hawking and realized that his job was called cosmologist. And so I wanted to be a cosmologist. I wanted to do what he did.
And you did list Stephen Hawking as a big influence for you, and you got a chance to meet and somewhat work with him.
I worked in the same department as him. I spoke to him a few times. I spent some time at Cambridge University doing a postdoctoral research fellowship, and for a while I was there as a graduate student as well. Before that, spending some time doing some research and taking some courses. So I was around his department a lot, and I would go to the same seminars and things. And I gave a talk that he attended one time, and that was frightening because I was a graduate student, and he was like my ultimate hero in the audience. And I was talking about primordial black holes, which is the subject that he was very involved with in the development of that topic. And I did end up sort of going to dinners that he was at and talking with him a little bit. So it was neat to be at a point where I was, definitely a cosmologist and definitely in his field and in his department. So.
And they say to never meet your heroes, but do you have any regrets? And
oh no, I mean, he was an interesting, multifaceted person. There were ways in which he could be obnoxious to people. He was fine to me, and I don't know a whole lot about the rest of his life, but all my interactions with him were totally fine. So
I just have a random story that I'm going to throw in that's totally off topic, other than being your hero. When I was 10, I really wanted to be a professional wrestler.
Oh wow!
And growing up watching like 80s, early 90s wrestling, I had the chance when I was about 13. I met King Kong Bundy, and I
Okay.
was the same height. It really just gave me a lot of disillusionment of King Kong and the name. So that's my side story of meeting. He wasn't even a hero; he was a villain. But
Right.
and I want to know two things. Normally, no one is ever upstairs. I don't know if you're hearing the music and the walking around. Great, because I hear it, and it's driving me crazy. Normally, no one's ever upstairs when we do these. And two, anyone who's watching this, if you have any questions, whether you're watching on Facebook, YouTube, or Periscope, you can use the comment feature, and we'll mix those questions in when we can. So your book, you talk about the 5 most likely ways or most possible ways that the universe could end as we know it right now. In the most brevity, with the most brevity of terms, can you get into the Big Crunch, heat death, Big Rip, vacuum decay, and the bounce?
Sure. Yeah. So these 5 are the ones I chose that were sort of representative of different ways that we think about the end of the universe and the possibilities that I encounter most in the cosmology literature, basically. So the Big Crunch is an idea that's been around for a very long time. The idea that the universe that is currently expanding might at some point crash back together and destroy us all in a giant sort of compression conflagration. So that's not so likely based on what we know now. More likely is what's called the heat death, which is where the universe is currently expanding. It will continue expanding forever. It will accelerate in its expansion. And basically the universe just gets very cold, very dark, very empty, and everything sort of decays and fades away. And that seems to be where we're headed. That's apparently the most likely. Kind of a sad, anticlimactic sort of story. But there are some more exciting possibilities, such as the Big Rip, which is where the expansion continues and accelerates, but actually gets stronger as well, and will sort of eventually start pulling apart galaxies and tearing solar systems apart and eventually ripping apart the entire universe. And that one's quite unlikely as far as physicists know. It's a lot of physicists I talked to said that really can't happen for various theoretical reasons, but we can't entirely rule it out observationally. And it's something that people have talked about as a possibility. So that's an exciting one. And then vacuum decay is my personal favorite, which involves a sort of bubble of death spontaneously appearing somewhere in the universe, expanding out and destroying everything. And then the final one that I talk about in the book is, so I call it the bounce. It's really a number of different possibilities for bouncing or cyclic cosmologies. So scenarios where the universe would cycle from beginning to end, or maybe there was a previous phase of the universe that started our Big Bang and then we're coming out of that. So there are a couple of ideas where the universe could repeat in some way or go through a transition.
And on the topic of vacuum decay, and we saw on Twitter yesterday, I'm not a science person. I should rephrase that. I love science. I'm horrible at comprehending it to the fullest potential. So from what I gathered from vacuum decay, it seemed to be the only one that we could potentially experience before the sun engulfs the Earth in flames.
Yes. Yeah. No, it's definitely, it's very unlikely to happen soon, but technically it could happen at any moment, which is one of the things that makes it exciting to think about. Whenever I talk about vacuum decay, I need to make it clear you should not worry about vacuum decay, because people will send me messages and say that they are scared. And I understand that there's a lot of things about the universe that are unknown and potentially frightening. And especially if I tell you that the universe could destroy itself at any moment, I understand why that's a scary topic. But I do want to emphasize that we think it's probably very unlikely that it could happen anytime within the next 10 to the power of 100 years. So 1 with 100 zeros, that many years. It's extremely unlikely to happen anytime between now and then. And anyway, we're not sure that it can happen at all because it's based on some theoretical ideas that we don't know for certain if they're valid, and there are some reasons to believe maybe they're not. So, lots of reasons not to worry about it, in addition to the fact that it would be painless and very quick and you wouldn't even notice. And, what could you do anyway? So I think that it's my favorite from the perspective of it would be, fairly gentle in the sense that you probably wouldn't notice it, or you definitely wouldn't notice it. You wouldn't feel it or anything. And also that from a physics standpoint, it's got the most interesting kind of mechanism, because basically the entire universe hinges on a quantum tunneling event, a transition that is a sort of fully probabilistic random event at some point in the universe. And then that at the subatomic level could then propagate throughout the entire cosmos and destroy everything. And that's a very interesting idea if you're a physicist. And that's a very cool kind of thing to study as a researcher.
And we had a question in from James. Congratulations on becoming a pilot. Has your experience learning to fly affected your work in science and cosmology?
I think that it's kind of more the other way, that being a physicist has affected how I think about flying and how I experience flying. So, one of the things that you do when you're learning to fly airplanes is you learn how airplanes fly, like why, like what is the physics of that? How does it all work? And there's a lot of technical stuff that you have to learn to be a pilot. A lot of things like dealing with vectors and coordinates and things like that. And I think being a physicist made a lot of that a lot easier for me and a lot more intuitive. So that's been cool. And I think also being a physicist makes a lot of that just appeal to me more. Like one of the things that appealed to me about becoming a pilot is that it's hard and complicated and technical. And I think that maybe being a scientist makes me gravitate toward things that are hard and complicated and technical in a way that maybe other, it's less common for other people. So I definitely think it's gone in that direction. I don't think that flying has really affected how I think about the universe, but it has been a different kind of perspective on the world, I guess, just seeing it from a very different kind of place.
We'll segue from that into, I love that you had referenced the overview effect that astronauts have had. Can you just explain for us what the overview effect is?
Yeah, so there's this idea that when you go into space, being able to see the Earth from above and from sort of outside the atmosphere changes your feeling about the world, about humanity, about how we should deal with each other as people, changes your perspective on national borders and conflicts and all of that, because you suddenly have this very visceral understanding that we are contained on this fragile little rock all together in the void of space, and that fragility and that sort of connectedness becomes very very sort of clear if you go out into space. And the reason that I talk about that in the book is that I feel that one of the ways you can get closer to that feeling without going to space is by learning cosmology, by contemplating the universe and our place in it, and having a better understanding of how we fit into the narrative and the story, of the cosmos, of the beginning of the universe, the end of the universe, how our world slots into that, what our place in the cosmos is. I think that thinking about cosmology and really understanding what's around us and how we got here and where we're going, I think those are things that can give you a little bit of a hint of that same feeling of that interconnectedness, that perspective that astronauts get.
I love, as many people do, Carl Sagan's pale blue dot, and
Mm-hmm.
Great summary and summation of what you just said.
Yeah. He says astronomy is a humbling endeavor,
Yes.
and that having that perspective can help us to deal more kindly with one another. I love that way of phrasing it.
Yeah. I'm just looking at the another question. Oh, different James. Same initials. Your book is fantastic, and you communicate very complex ideas very, very well, even to dum-dums like me and me. How did you learn to write so well?
Well, that's a very flattering comment. Thank you very much, James. I've done a lot. I've just done a lot of writing. I think that for me, I've done a lot of writing and I've done a lot of reading, and it's one of these things where by practicing, you do get better. And so I've been writing since I was a little kid. I would write little stories. I wrote a ton of really terrible poetry as a teenager, and I've always been a very avid reader, mostly science fiction, because that's what I'm into. But I'm constantly reading. And so I have a great appreciation for language. And one of the other things that helps me a lot with my science writing is that I spend a lot of time talking about science on Twitter. And that might seem disconnected from writing a book, but you really do get a sense of how best to explain complex topics in a simple and concise way if you're doing it on Twitter, because people will give you immediate feedback if they are confused, and you can find out very quickly what resonates with people, what people's misconceptions are. I know a lot more about wrong ideas that people have about the universe through Twitter, and how to better communicate the real ideas there. So just having more dialogue with people who are not physicists helps a lot, and just doing a lot of writing and doing a lot of reading. I think those are the most important things for the kind of writing I do.
With your mention of the amount of reading that you do, I could tell. I loved all of the quotes that you used and selected for leading into each chapter. I wanted to read the one that kicks off the epilogue from Alistair Reynolds, Pushing Ice. But if nothing we do here has any guarantee of lasting, if even the best gestures have only a slim chance of outliving us, is there any reason not to just give up? Every reason in the world, Rudd said. We're here and we're alive. It's a beautiful evening on the last perfect day of summer. So it kind of goes into, and I see a couple of questions coming in that I'll get into, but what does this mean for all of us? Knowing that the universe will end, knowing that the Earth will probably end before that.
Yeah. Well, I mean, that's something I really spent a lot of time wrestling with while writing this book. I am not somebody who is comfortable with the notion of death. Okay, so like some people are pretty chill about the idea, like, oh yeah, I'm gonna die someday. That's fine. I'm not okay with it. I don't want to die. I don't want anybody I care about to die. Like I find it really disturbing and really upsetting. Like that's not something I'm comfortable with. And so contemplating the entire universe dying is also quite confronting if you're somebody who is uncomfortable with the idea of impermanence. And so in writing this book, I thought a lot about what does it mean that the universe will end. I'm very attached to the cosmos. I'm very attached to existence. And what does it mean that will end? And also, what does it mean for humans to know that someday we will all be forgotten, right? Because at some point, like our existence will be erased and nobody will remember us, and there will be no trace that we were ever here, everything will be destroyed. And in some ways, none of this will have mattered, at a certain point. And what does that mean for us right now? Does that take away the meaning of existence? Like, what is the meaning of life if it will have not mattered at some point, if we have no real legacy in the cosmos? And so I really struggled with that. I really thought about that a lot in the course of writing the book. And the epilogue is really all about wrestling with that question. So when I was researching the book, I was going around and visiting a lot of my colleagues and asking them questions about the end of the universe and about what we're learning about astronomy right now and where things are going to go in the next few decades. And in the course of asking those questions, I made sure to ask everyone also, how do you feel about the end of the universe? Like, what emotions does that bring up for you? And it was fascinating to hear how everybody thinks about that. These are professional physicists and cosmologists, people who study, dark energy or, the Big Bang or whatever, these big questions. And there was a really big range of responses. Different people had very different ideas about the end of the universe and very different feelings about it. And I found that just really interesting and exciting to get that perspective from people. So for me, I think that my kind of takeaway from this whole thing is that if we want existence to have a meaning, we have to come up with that ourselves. We have to find our own meaning in the universe and sort of create our own meaning and have our own purpose that does not depend on somebody after the fact saying, well, this is what it all came down to, that it has to be really, we have to decide to make life meaningful. That was my sort of takeaway for the whole thing.
I enjoyed this, especially your quest during the epilogue to find some sort of answer, some sort of meaning. It really kind of humanized you, because, and this could be my own, but I feel like other people feel the same, where, oh, as a scientist, they're just looking at numbers and facts and figures, and they remove their emotions from this. And I'm glad that you put your emotions into it, because it's the end of the universe. Just for a plug, and it might offer you some help, as somebody who has a lot of anxiety about my own eventual demise. There's a book called How to Die, a book about being alive by Ray Robertson. We had a chance to have an author talk with him a couple months ago. After that talk, and still, I don't know how long it's going to last, it's been the most calm and okay I've been with the idea of death. So you might want to give that a read or a watch. We have a lot of questions that came in. Anthony, it kind of, I hope that we kind of answered your question without even seeing it. Does the end of the universe actually prove that everything happens for a reason? You touched on that. I think
I would say almost the opposite.
Sorry, Anthony, because I know Anthony, and I know that I think he wanted a better answer, a different answer. So, Walt, how can we predict the detectable products of dark matter? I'll bring this up so you can see it. Of dark matter particle collision annihilations event. I don't even know what that question means.
So I think I should say a little bit about dark matter first. So dark matter is my main area of research. The end of universe stuff is a new area for me, but I've been working on dark matter for a long time. And the idea behind dark matter is that we observe in many different contexts in the universe, we observe that there's more gravity than we can account for with the matter that we see. So matter is anything that has gravity, like, atoms and molecules are matter, planets and stars are matter. And when we look at galaxies and we see how stars are going around galaxies, we see that the stars toward the outside of the galaxy are moving around so quickly, there has to be more matter holding them in. And then we see other signs of this. We see signs that dark matter, that there's extra matter that's bending space and changing the way light passes through the universe. We see signs of extra matter when we look at the distribution of galaxies on the largest scales in the universe, and the distribution of matter in the very early universe, which we can see through looking at the background light from the very early days of the cosmos. So there are all these different ways that we see that there's just extra matter that doesn't interact with visible light in any way that we know about. It doesn't seem to emit light, it doesn't absorb light, it's invisible from that perspective, but it does seem to have gravity. It does seem to affect the matter around it through gravity. It affects space and has its own gravitational pull. And there are a couple of ways we're trying to figure out what that dark matter is. We think it's probably some kind of new particle. And there's precedent for that. So we know that neutrinos are a kind of particle that also have some mass but don't interact with light. That's a totally normal thing that exists in the universe, that neutrinos are out there. We know that neutrinos, at least the ones we know about, cannot be the dark matter that makes up the bulk of galaxies, but something like a neutrino seems like a reasonable idea. So a few ways that we look for these things is we hope that maybe when two dark matter particles collide in just the right way, they might produce an annihilation that creates particles that we can see. So it's possible that, for example, two dark matter particles might collide and then create an electron and a positron, which is an antimatter version of electron. And then we could see those as they come out of that collision. So far, we haven't had any success in really nailing that down. We've seen a few kind of hints of maybe there's something like that happening in the cosmos, but we're not really sure. We've also created dark matter detectors where we hope that maybe eventually sometimes a dark matter particle might run into a regular particle and impart a little bit of energy through weak nuclear interaction, so a certain kind of particle interaction on the subatomic scale. We don't have anything conclusive in that regard either. We're even trying to create dark matter through particle collisions at accelerators. And so far, that's come up short as well. So a lot of people take that to mean that maybe dark matter isn't real, but the evidence all points to the idea that dark matter is very real. It just doesn't seem to interact in ways that our detectors are particularly good at finding. And that's totally consistent with the evidence we see in the cosmos. So I think that it's a matter of, we're going to keep looking. We're going to keep trying to find new creative ways to look for this stuff. We're going to keep thinking of new, different kinds of ideas about dark matter that might be different from the original notion of just this particular kind of particle. So hopefully we'll find something. Hopefully we'll figure out what this stuff is made of. But the idea that it's real seems to be inescapable. There's really just so much evidence for it out there. Unfortunately, there's evidence for invisible matter rather than stuff that we can easily detect. So, we're going to keep looking.
We have no shortage of questions, but I do want to remind anyone or let anyone know that came in late. If you have any questions and you're watching on Facebook, YouTube, or Periscope/Twitter, you can use the comment feature and they'll pop over for us to see. We do have a question from Bradley Brown. What wisdom and tips do you have to share on the art of effective science communication?
I think so. My main thing about science communication is to really, really kind of listen to people, find out what people are interested in, what they know about, where they're coming from, and to try to, speak in terms that people understand. I know that sounds very. That probably sounds pretty basic, just, listen to people and talk to them in terms they can understand. But I think that there's a lot of times scientists are a little bit reluctant to, to simplify or to use analogies too much or whatever. And I think that if you can come up with a useful analogy and you can make it clear that it's not a perfect representation, I think you can get a lot of information across that way. And if you can use concepts that people are familiar with, ideas that people might already be excited about, to put to put something in context, to bring it closer to somebody's experience, that's very helpful. And just like, really, seeking out feedback and really listening to how people respond to what you're saying, and, not ever acting like someone should know something already. I think that one of the pieces of advice that I heard early on is to assume that your audience is intelligent but not knowledgeable, right? So they're very capable of understanding what you're talking about. They just don't know it yet, and that's not a something to be concerned about. There are a lot of things I don't know until someone tells me, and there's no reason that somebody ought to already know something to do with the structure of an atomic nucleus or something. Like, there are a lot of things I learned in high school that I forgot, and I think that that's true of a lot of people. And so there are topics that I might talk about on Twitter or something, and a lot of people might say, "Oh, that's really interesting. I didn't know that," or "I never understood that before." And then occasionally other people will say, "Oh, how could you not know that?" It's like, well, we don't all know everything. We forget things. We miss stuff, whatever. There's absolutely no shame in learning something new. And I think it's an amazing experience to be able to help somebody understand something for the first time. And if that means talking about something that to me seems very basic, or that, that other people might think you should have learned already, I don't see a problem with that. I think that if there's, if it's possible to help someone have that moment of understanding, that sort of eureka moment, that's completely worthwhile and super important. I mean, and people can get fascinated by anything if it's presented in a way that's accessible and interesting. I mean, I remember one time I tweeted a 12-second video of water boiling in a pot, and talked about convection and fluid dynamics, and people were really excited about this. It's water boiling in a pot. We see this stuff every day, but when you think about the physics of it, when you think about how how the fluid is moving, and what the heat is doing, and how the light is bending around through these warmer, cooler fluids, like, it gets really interesting, and it's a matter of like taking the time to think about it, to put it in that context. I think that like being able to share your own enthusiasm and bringing it to something people might not have thought about in that way before is a really helpful thing to be able to do.
And I think the idea of meeting people where they are is simple in concept, but not always utilized as much as it should.
Yeah.
Where I am is from a humor standpoint, and I love the humor that you bring in. Generally, when I'm reading something, I skip over the footnotes. It's just that's who I am. Don't skip the footnotes in this book.
No, all the best jokes. All the best jokes are in the footnotes. All the things that I couldn't justify putting in the main text are in the footnotes. So.
I really appreciated that. The footnotes were funny. We have a question coming in from probably I don't know how to say the name, but you discussed how humbling the study of cosmology can be, and that it can lead us to be kinder to one another. As a sci-fi fan, do you have any books, authors that express this spirit? I read a lot of science fiction. I watch a lot of science fiction as well. I am not into dark and gritty and pessimistic science fiction. I like science fiction that assumes that we will learn to be better and nicer to each other, and like we will learn how to make society good. So I prefer Star Trek to Star Wars because I dig the utopian thing. I know that a lot of people find that unrealistic or whatever, but I like the idea that we will find a post-scarcity society and, treat each other with respect for the most part, and be nice. So
I'm into that sort of thing. I've been reading a lot of science fiction recently that is just really interesting sort of meditations on how sort of interplanetary, interspecies societies might work. So Becky Chambers has a series of novels, the Wayfarer novels, that are all about sort of people kind of learning to get along with other species in space. And her most recent one, it's called The Galaxy and the Ground Within, or something like that. I just finished reading it. Just came out a week or so ago, or two ago, or something like that. And that's really all about a group of aliens, of different species and cultures, trying to, find common ground and be tolerant of one another. And I really like that that kind of vision of interconnectivity and finding ways to not center our own experience, but get along with one another. So I like that kind of thing. There are so many great novels and so many great science fiction authors out there.
Have you had a chance to read Project Hail Mary yet by Andy Weir?
I have not, no. I read The Martian. I enjoyed that. I haven't read his more recent stuff.
I haven't read Artemis. I haven't heard great things. Project Hail Mary is much more comparable to The Martian in that it's mostly one guy solving a lot of problems, but there are, I don't want to spoil anything, but there is the greater dynamic of the relationship building. And he does it really well. I think you'll really enjoy it. I'm plugging a book that's not yours, but I read it recently and it came out recently and I love it. In terms of what's next from the research end, you had talked about the VRO telescope. What can something like that teach us? What are we expecting or hoping to learn within the next few years and beyond?
Yeah, so in the next few years, there are a number of telescopes and observatories that are coming online that are just going to show us much, much more of the universe. So you mentioned the Vera Rubin Observatory. That's going to be taking a survey of the sky and going to find billions of millions or billions of galaxies and supernovae, and really map out how the universe is put together, like where the structure is in the cosmos. Then there's the James Webb Space Telescope, which is going to be looking at some of the earliest galaxies in the universe. A couple of other telescopes that are going to be doing similar things in space, Euclid and the Nancy Grace Roman Space Telescope. They're just going to show us further and further back in time and how the early galaxies formed, and that's connected to the idea of the future of the universe as well. Because if we understand the past, we have more information about to extend into the future. And then there's also gravitational wave observatories. So we have instruments now that can detect the vibration of space itself when black holes collide in other galaxies. I mean, it's really astonishing technology that we can actually measure how space responds to extreme gravitational events. And that is allowing us to not only learn about black holes and about how gravity works, but it's also giving us a new way of measuring the cosmos. And that's, I think, going to lead to a much greater understanding of sort of the physics that governs the universe. And that's super exciting as well. So there are a number of sort of observations that are happening. And then on the physics side, on the sort of experimental physics side, we're getting new and more powerful collider experiments. We're going to learn more about the fundamental particles that make up the universe, and that tells us about the early universe, and it could tell us about things like vacuum decay, which could determine something about the end of the universe. So, it's a really exciting time to be studying cosmology, and especially if you're also interested in the sort of fundamental physics of the cosmos.
And there was a question that came in that we did address, but we can talk about it some more. Noreen asked, do you have any desire to travel into space?
Oh yeah, definitely. Yeah. So I've applied to NASA's astronaut program a few times. I did make the first cut once. So they, that time when I applied, there were something like 6,000 applicants, and then they chose 400 to be on the highly qualified list. And then, they had medical checks and references and things, and then went on from there. So I made it to the highly qualified list, and I didn't get beyond that. But I would absolutely love to go to space, and I will continue applying to NASA for the astronaut program if that continues to be, if they keep having open applications. I think it would be a lot of fun. I don't know. I would love to get out there. They unfortunately, theorists are not that useful on the space station. So the problem might be that they really need people who know how to take the space station apart and put it back together again, and not people who can talk about how stars work. But maybe I can prove my usefulness in some other way.
I like flying the whole ship.
Yeah. I'll be the
pilot. I really appreciate the constant pursuit of knowledge that you have. That you don't just try to find what makes sense and say, oh, well, that works mathematically, that must be the answer. But how frustrating is that? Like you talked about the standard model of particle physics, and that it makes sense, but you're trying to have it not.
Yeah, so we're in a kind of weird position with particle physics and with cosmology right now, which is that we have these kind of paradigms that fit all the data more or less as far as we can tell, and that have been around for a number of years, that keep passing these tests, but we know that they're not the ultimate theory, right? So in particle physics, we have the standard model of particle physics, which describes every interaction that we've ever seen in a particle accelerator or detector. And with a few exceptions, all the experiments agree with the standard model. There are a couple of places where there's a bit of disagreement that may or may not be significant enough to really count. But we know that it can't be the whole picture. We know that there has to be some better theory of how the universe works. And we know that partially because the standard model of particle physics doesn't include dark matter. It doesn't include dark energy, which is this other thing that governs how the universe works. And it doesn't work well with the theory of gravity. And so there's something missing, and we don't know what it is. And so it's a bit frustrating to say, each time we do an experiment, like, well, that worked as we expected. That's a bummer. Like we need to find discrepancies. And fortunately, there have been a couple of experiments recently that have seen some discrepancies, and we don't know if they're going to pan out yet. They could be statistical fluctuations, but there are a couple places where it might be pointing in a new direction, and that would be really, really useful and important for us.
And I was looking at, this is one of the random questions that I wrote down last night. Why should we not be concerned about CERN destroying the world?
Well, there are a number of reasons, but the main one is that like CERN, so what CERN does is they collide protons together at very high energies. When we say very high energies as human beings on Earth, we are talking about up to a particular scale that is nowhere near the kinds of energies of collisions of particles in the universe. So the universe is much, much better at this than we are, right? We can smash our little rocks together, but the universe is doing extraordinarily high energy particle collisions all the time, and not just out at other galaxies, but like high energy particles are constantly slamming into the moon or into our upper atmosphere. And so the kinds of collisions that CERN is able to do are just nothing compared to the kind of collisions that are happening billions of times a day, a couple hundred miles above us, and none of those are destroying the universe. So so there's really no reason to think that the kind of collisions that we can produce on Earth are and at all special, because they've been happening for billions and billions of years across the cosmos and even nearby. So it's people always get a little nervous when we have some new technology that does something that we've never done before. But in this case, it's not that it hasn't been done before, it just hasn't been done by us in a place where we can look. Okay. And so all we're doing with CERN is we're able to observe these interactions that are happening all the time in space.
And kind of into that realm of misunderstanding. And before we get into that, we're approaching the end of our hour with Dr. Katie. And so if you do have any last questions, feel free to plug those in now. If not, you can track her down on Twitter. She's very responsive. And in that world of Twitter and discussion and debate, do you feel that the world that we exist in now is, I use the term anti-science. Do you think that is a new problem, a bigger problem than it was when Galileo was prosecuted for the damning idea that the Earth is not the center of the galaxy or the universe? Is this a bigger problem now than it was before?
I think that I think anti-science is not the term that I would use. I think that most people like science. Most people find science interesting and broadly think that it's a good thing to be doing, and broadly think that we should base a lot of our lives on science. And furthermore, if you do polls, most people trust scientists. There's a great deal of trust in scientists, more than on average in politicians or public officials. We're somewhere around where doctors are in terms of how much people trust us. In the sense of, like, are we actually going to tell the truth about the science? I think that what gets complicated is that there are a lot of political pressures on people in various directions these days that can make it difficult to make it difficult for people to know how to weigh what scientists are saying versus what their political or community leaders are saying. And also, it's not always clear that just because a scientist says something, that necessarily leads to a particular policy outcome, right? Because policy and science are not necessarily the same thing. And there are times when we have other considerations that we should think about other than just what is the result of a particular science experiment. And so I think that a lot of these questions are really complicated and depend a lot on people's political feelings, also people's identities. There are certain times when, sorry, there's a moth. There's certain times when how people see themselves in the world can affect how they react to certain kinds of scientific news and recommendations. So I think that what we as scientists need to be better at is helping people know what we're doing and why we're doing it. And I think a lot of times when you see sort of hostility toward experts or toward scientists in particular ways, it has to do with the way that people might not understand what we're doing or why we're doing it. There's a phenomenon that comes up a lot where people think that scientists are sort of cold and amoral, that maybe we're not doing things for the right reasons. Maybe we don't really care about people. Every once in a while, there's some kind of suggestion that we're in this for the money, which is not how it works in academia, I will tell you. So, I think that one of the things that we can do as scientists to be more accessible and to be more, to help people understand what we're doing and why, is to be on social media or to talk to the public more, listen to the public more, find out what people are interested in, what they care about, what their concerns are, and share why we're doing what we do and how we do it, how we come to a consensus, how we come up with new ideas, how we test our theories. I think all of those things can be really, really helpful to to help people contextualize what we're saying, and in cases necessary, help trust what we're saying, or at least know how to evaluate the statements the scientists make.
And this could be a good final question, and it can be a touchy one for somebody. This is your first book, you're writing all the time, but for full-time novelists, the idea of when's your next book coming out? Hi, Katie, I heard you speak for the first time in the Ologies podcast a while back, and I thought you were brilliant. I want to ask if you were planning on writing another book anytime soon.
Well, thanks for that. I do hope to write another book, not anytime soon though. So one reason for that is that I'm still a full-time academic, and I have to write grants and research papers and teach classes, and so there's a lot of stuff that I need to kind of catch up on, having taken a little bit of time away from that to do the first book. But also, I really want to make sure that my next book is a topic that I really want to delve into, and writing a book takes a couple of years. I want to make sure that I have a really good subject, and that I'm really dedicated to telling that story. So I'm still kind of trying to figure out exactly what I want to work on next in terms of a book, and how I want to present it. So once I have that all sorted out, I do hope to write another book. But it's kind of hard to follow, like, destroying the entire universe. I don't really know. I don't really know where to go from there. So I'm still kind of thinking about it.
You peaked early.
Yeah.
Well, I want to thank you so much. The End of the Universe by Astrophysically Speaking by Dr. Katie Mack is available in our store, on our website, which I'll click the link into now. And if it's not in your independent bookstore, please ask that they order it in, because it needs to be. Our next event is going to be in 2 weeks with Tono Bilstead. It's called The Anatomist's Tale, Being the Confessions of an Unwilling Pirate Marooned for a Time Upon the Shores of New Madagascar. It's a long one. The book is short. But it's a great book that's set in the 1700s of the British Empire, about a man who's a surgeon who is framed by the captain of a ship, sent to a prison, and the book is told over the course of time as he's on this island prison, and people are visiting him, and you get into the whole politics of 1700s British Empire. It's a good read. So tune into that in a couple of weeks. Thank you all so much for tuning in, and thank you again, Dr. Katie Mack.
Thanks for having me. This was fun. And thanks everyone for questions.
Thanks.